Sorry for that interruption. Put my phone on do not disturb, so nobody's gonna bother us now. All right, I was at converting 25 meters cubed to millimeters cubed. So we start off with the idea that 1,000 millimeters are in 1 meter, linear, but we're converting to cubic, so we're gonna raise it to the power of 3. Then when you raise that to the power of 3, the 1,000 can be rephrased as 10 to the power of 3. Raise 10 to the power of 3 to the power of 3, you get 10 to the power of 9. Everything else comes cubed. It allows you to delete the meters cubed, and the answer becomes 25 times 10 to the 9 millimeters cubed. And in scientific notation, that would be 2.5 times 10 to the 10. So 25, make it 10 times smaller, 10 to the 9, make it 10 times bigger, and you go up by a power, and that's your answer in scientific notations. Notice I'm not using calculators because they're not necessary. That's the strength of the metric system. It allows you to do to make a lot of calculations without resorting to the use of calculators if you know just a little bit of exponents and how to rate and your exponent laws and your conversion factors, your linear conversion factors. The next thing I wanted to do was how to work with density and rate. Most equations you'll meet in high school science have 3 variables in them. Usually they give you 2 of the variables and you have to solve for the third one. Sometimes they give you 1 variable, 2 variables. Sometimes they give you other 2 variables. You just have to know how to rearrange the equation to solve for the variable that you want. Density is equal to mass over volume. Density is a measure of unit mass per unit volume. It's usually given in grams per centimeter cubed. Okay, sometimes they say grams per ml. The two are interchangeable. Usually for liquids they use ml. For solids they use centimeter cubed. It's not a big deal if you interchange it. Sometimes you could even see grams per cc. That's this. Basically, it's the same thing. Centimeter cubed, they just say cc. You're all good at acronyms, right? So it's not hard. Let's do a couple of examples where we work out the density of things. Density of gold. The density of gold is 19.3 grams per centimeter cubed. How big a cube would of gold would weigh 1 pound? You just have to know a couple conversion factors. First of all, 1 kilogram equals 2.205 pounds. That's your conversion factor. Solve that equation, and so let's make it 1.00 pounds, so we have 3 significant figures in our final answer. Well, let's make it 4 because we have 4 there. And now let's solve for what 1 pound of gold gives us. So 1.000 pounds times 1 kilogram per 2.205 pounds gives you, notice I put pounds on the bottom. Why? Because I want to cancel pounds. 1 divided 2.205 gives you, we can turn that one on because it causes glare here. I'm just going to see my readout. Yeah, you get 0.453514739 kilograms. And we know there's 1,000 grams per 1 kilogram, so that equals 453.5, we'll stop it there, grams. So that's how many grams of gold we have. It's about 28 grams, 28 bucks a gram, I think. Let's say 30 grams, 30 bucks a gram, 400 grams. It's $12,000, $12,000, more than $12,000.
per pound of gold?
Okay, so density equals mass over volume. We have the mass. We want the volume. We know the density because they gave you the density equals 19.3 grams per centimeter cubed. So we're going to solve for volume. Now, if you take the equation and you multiply both sides by volume, you can cancel volume over here. So you're gonna get that mass is equal to density over volume. And if you want volume all by itself, you can divide both sides by density. Densities will cancel on this side, and what you'll get is that volume is equal to mass over density. That's what we're doing mathematically. And you should be able to do that in grade 11 or 12. You shouldn't be getting little triangles with how to learn the algebra, okay? The algebra is going to make it easier for you to do. You can apply algebra universally. You don't have to memorize 1,000 different formulas if you know how to do the algebra. It's just a simple set of rules. So volume equals mass over density in this case. The mass we found out was 453.5 grams, and density is 19.3 grams per centimeter cubed. The grams are going to cancel. You see that the centimeter is in the denominator of the denominator, so it's going to become the numerator. 453, I still have the number in my calculator. I'll divide by 19.3, which is the density of gold, and that gives me, excuse the light, that gives 2.3498 173 times 10 to the minus 2. No, that's not right. Yeah, it's not negative 2. Let's try that again. 453.5 divided to 19.3. Yeah, I don't know what happened. I got some crazy number here. It's not right. Change. We get 23.497. .093 centimeters cubed. Now, if you were to find out how tall that cube is, remember a cube is length times width times height, but length and width and height are all equal in a cube, so you could say length cubed is going to equal the volume. So if you take the cubed root of both sides of this equation, you'll get that the length is equal to cubed root, right? If you take the cubed root of something that's cubed, you get back to the original thing. So let's take the cubed root of this number. My glasses are here. Excuse my blindness. You take the cubed root, which is right here, and you get a height of 2.86. So the cube would be 2.86 centimeters high. Just a little over an inch high, and give you 1 pound of gold, or 1 pound of gold. All right, that's how to work with density. There's one question where we work with rate. I'll just give it an easy one that I'm going to make up myself. It's another 3 variable equation that you should be fairly familiar with. I've used it before in class. Okay, you know that rate times time is equal to distance. So if you're going, for example, a rate 100 kilometers per hour, and you travel for 5 hours, how many kilometers did you travel? Cancel hours, 5 times 100, 500 kilometers. Okay? You can turn just about anything into a rate. If you eat 2 apples a day for 5 days, you eat 10 apples. Your rate is 2 apples a day. Okay? 2 apples a day for 5 days. Days cancel, and you ate 10 apples. So that's how you show your rates. Here's the rate, here's the time, and here's the distance. The distance is that you ate 10 apples. So you have to decide at some point if you get that kind of related rate. Actually, that's not a related rate. Scratch that. If you get a situation where something is a rate for a certain amount of time, the distance, you have to decide what the distance is. Sometimes the rate is not as clear. You know, eating 3 ice creams a day is a rate of ice cream eating. Okay, so if you eat for 3 days at that rate, you'll eat 9 ice creams. So the distance that you've traveled is 9 ice creams in a sense. That's how you work with that. Last thing I wanted to do with you today is unit conversions. When you make unit conversions, you have to know which way to write your unit. You know, if you have 1 dozen, let's talk eggs. 1 dozen equals 12 eggs. But you can write that 2 ways as a conversion factor. You could say 1 dozen per 12 eggs, or you could just as rightly say 12 eggs per 1 dozen. But it's upon you to choose which one of the 2 is the correct one to use. How do you choose what to use? It's what you want to eliminate. So if each chicken lays 6 eggs a week, how many dozens in 5 weeks? I have to make it easy, 6 weeks. Okay, answer. We have a rate here going on. Okay, so you got a rate, you got time, and you want the distance. That's the number of eggs. The rate is 6 eggs per 1 week. The time is 6 weeks. So your weeks are going to cancel, and your distance is 36 eggs. Okay, now suppose you were asked how many dozens. Well, 36 eggs times, you got to pick one. Which one are you going to pick? The one where you have dozen on top and eggs on the bottom, or one where you have eggs on top and dozen on the bottom? Well, you want to get rid of eggs, and here it's in the numerator, because you could put this over 1. It's 36 eggs over 1. That's still 36. So you got to put the eggs, if you want to eliminate eggs, you got to put eggs in the denominator. So you're going to use this one. So 1 dozen per 12 eggs. And that gets rid of eggs. So you got 3 dozens. Okay, that's how you work with units. It works with moles, it works with atoms, it works with molecules. You can cancel words and you can cancel numbers. Also remember that trick I taught you at the beginning of the year, where you could have a big long set of numbers, something like if I had to multiply a bunch of fractions, 1 over 2 times 2 over 3 times 3 over 4 times 4 over 5 times 5 over 6 times 6 over 7 times 7 over 8 times 8 over 9. You might be tempted to reach for your calculator, but that would slow you down, because you can cancel things. They don't even have to be directly above each other. They can be anything on top can cancel with anything on the bottom, as long as they're cancelable. And if they're the same, they're obviously cancelable. So you can cancel 3 with 3, 4 with 4, 5 with 5, 6 with 6, 7 with 7, 8 with 8. What are you left with? 1 over 9 is your answer. And you can do that. In fact, you don't even have to cancel it. You can just look at it and say, well, if they all cancel, it's 1 over 9. You get the answer without punching in a whole bunch of numbers into your calculator. It's just, that's how you do math when you know your basic algebra and arithmetic. Things get sped up. You should also know your times table. I shouldn't have to say it, but something evil happened in education. I don't know who did it. I know who brilliantly came up with the idea that you shouldn't teach kids the timetables, but I get kids in grade 12 who still don't know their times tables. I don't know. I don't know who's making these decisions. Okay, let's do some practice, and then I'll give you a little bit of homework related to that. How many micrometers are in 1 cubic mile? Okay, that's going to seem challenging to you, but some of you have done it already. I was giving these kind of questions on the periodic table test. Let me see if you're still with me here. Okay. What do you need for conversion factor? Well, 1 mile is equal to 5,280 feet. 1 foot equals 12 inches. 1 inch equals 2.54 centimeters. 1 meter equals 100 centimeters, and 1 meter also equals, what was it, micrometers, right? Equals 10 to the 6 micrometers. Okay, micro is like a little U, but with a tail. It's like a U with a tuxedo. Okay, so the answer to that is we have to first convert the mile. So mile times 5,280 feet per 1 mile. Raise that to the power of 3 because we're going in 3 dimensions, remember? It's a mile cubed. Times 12 feet per inch, also cubed. Times 2.54 centimeters per 1 inch, also cubed. Times 1 meter per 100 centimeters, cubed. Times 10 to the 6 micrometers per 1 meter cubed. That means that in 1 meter cubed, there are 10 to the 6 to the power of 3, 10 to the 18 micrometers. That's a ridiculously large number, but you don't have to worry about it because it's all written down here and your calculator can handle it. Your calculator can handle numbers up to 10 to the power of 99. If it goes higher than that, then you get an overflow and it says error. You can on your iPhones, I think you can go up to the 160th power. With your brain, you can go up to infinity power, especially if you know some basic math. Obviously, you wouldn't want to do this in your head, but there are ones when it's just powers of 10. You can go up to ridiculously high powers, which would never be practical anyway. 5,280 to the power of 3 times 12 to the power of 3 times 2.54 to the power of 3 divided 100 to the power of 3. You see, I said divided. Why? Because it's in the denominator. Times 10 to the 18. I'm just going to write 1 exponent of 18. Now I said 1 exponent 18. Why? Because when I press that exponent button, the times 10 appears automatically. Sometimes kids say 1 times 10 exponent power 18, but when they press the exponent button, the calculator automatically does the times 10, so their answer is 10 times bigger than the actual answer because they've already written a times 10 in there. If you press EXP button on your calculator, the times 10 part is automatic. Don't write times 10. Kids do it every year. Okay, the answer is 1 mile cubed is equal to 4.168,181.83 times 10 to the 27. Now you can test your results as well by asking Siri to tell you how much it is. You could say, hey, you know who, I won't say now because my phone will hear me and then it'll try to answer, how many cubic meters are in a cubic mile, and she will tell you the answer to about 1 or 2 decimal places. But then you can see if you got it right. For homework, I'd like you to try this. Convert 1 mile squared to femtometers squared. Okay, how much is how much is femtometers? 1 meter equals, okay, I gotta think about it. Nanometers is 10 to the negative 9. Picos is 10 to the minus 12. Femto is 10 to the minus 15. So 1 meter equals 10 to the 15 femtometers. Or you could say 10 to the negative 15 of a meter equals 1 femtometer. But use this one. This one is, I find this one easier because people like working with positive powers more. But you should be able to do it either way. Try to do that for tomorrow.